So, if you're building anything with LLMs, you've probably hit a couple of walls, right? They cost a lot of money and, man, they can be slow. Well, today we're going to show you how to smash through both of those walls with one super powerful technique: caching. Does this sound familiar? You build this awesome AI feature, you're super proud of it, but then you look at the bill and you see the lag time for your users. Yeah, it's a super common story. But the good news is you are definitely not alone, and there's a really clever way to fix this.
Okay, so every single time your app makes a call to an LLM, you're getting hit with this triple threat. First, the cost. Every single token, both in and out, costs money, and it adds up fast. Second, the speed. Let's be real, model inference takes time. And third, you've got rate limits. The providers literally cap how many times you can ask for something. Caching, well, that's our secret weapon against all three of these problems.
All right, here's the game plan for the day. First, we're going to talk about the high cost of AI. Then we'll pop open our caching toolbox. After that, we're doing a deep dive into 5 key strategies. We'll also get our hands dirty with the practical side of building a cache layer, talk about how to do it safely, which is super important, and then we'll finish up by looking at the amazing payoff. All right, let's jump right in. Section 1, the high cost of AI. And really, the subtitle here says it all. The whole game is about making fewer calls.
I love this quote because it is the absolute heart of everything we're talking about today. Just think about it for a second. If you can give a user a perfect answer without ever having to call the API, well, you've spent $0, you've had zero latency, and you haven't touched your rate limit. That's the magic we're chasing here.
Okay, on to Section 2, your caching toolbox. So let's figure out where we can actually use this stuff. And what's so powerful is that there are a bunch of different places you can do this. You can cache the most obvious thing, the final response to a specific prompt. Or you can cache the embedding vectors, those numerical representations of text that are so important for search. If you're using a RAG system, you can even cache the search results themselves. And if you have a really complex pipeline, you can cache those little intermediate steps along the way. Think of each one of these as a different lever you can pull to make your app way better.
All right, Section 3 is where we get into the nitty-gritty. 5 key caching strategies. The whole idea here is to match the right tool to the right job.
So, strategy number 1 is the simplest one of all, the exact match cache. It's exactly what it sounds like. If one user asks the exact same question that another user asked 5 minutes ago, why on earth would we pay to ask the LLM again? Nope, we just grab the answer we already have and serve it up. This is a huge win for things like FAQ bots or any kind of common support question.
Okay, strategy 2, the embedding cache. And listen up, because this one is a massive money saver. If you're using a RAG system, you are constantly turning chunks of text into those numerical vectors we call embeddings. And guess what? Those API calls are a sneaky and often major part of your bill. So by caching these embeddings, especially for documents you know aren't changing, you can literally save a fortune.
And while we're on the topic of RAG, let's talk about the RAG result cache. So, imagine a user asks a question, and your system goes off and does this big, expensive search to find, say, the 5 most relevant documents. Okay, great. But what happens when another user asks a super similar question just a minute later? Are you really going to do that whole search again? No way. You just cache the list of documents you found the first time. This makes your app feel incredibly snappy for common questions. Now, we can get even fancier. There's something called a partial output cache. This is where you save the result of just one step in a bigger process. For example, maybe step 1 is find the company name in this email. You can cache just that company name so that all the other steps in your pipeline can use it without having to figure it out again. And then there's the template-based cache, which is super clever. It's smart enough to see that a prompt has a basic template, and it just ignores the little variables, like a username, allowing it to reuse the same core answer for hundreds of different people.
Okay, let's move on to Section 4, building your cache layer. Now we're getting into the how-to, the practical stuff: storage, keys, and logic.
When it comes to storage, you've basically got 2 main options. First, an in-memory cache. It's lightning fast, it's simple to set up, and it's perfect if you're just building a prototype or running on a single server. But the moment you scale up to a real production app with multiple servers, you have to use a distributed cache like Redis. Yeah, it's a bit more work to set up, but it's shared, it's persistent, and it's built to handle a heavy load.
You know, the real heart and soul of any cache is the key. That's the unique identifier you use to look up the stored data. And a good cache key has 3 important qualities. It has to be stable,
meaning the same input will always create the same key. It needs to be canonical, which is just a fancy way of saying it ignores tiny differences like an extra space. And it has to be specific. You need to include anything that might change the output, like the name of the model you're using or even the temperature setting.
And the logic for how this all works? It's actually super simple when you break it down. Step 1, you generate that unique smart key we just talked about. Step 2, you check if that key is in your cache. If it is, boom, that's a cache hit. You just return the answer you already have, instantly. Job done. And if it's not there, well, that's a cache miss. You go make the real API call, but, and this is the important part, before you send the answer back to the user, you store it in the cache. That way, it's ready and waiting for the next time.
Okay, this next part is extremely important. Section 5, Rules for Caching Safety. We need to talk about what not to cache and when to get rid of old data.
And I cannot stress this enough. You have to be so careful about what you're putting in your cache. Just remember, a cache is just another type of database. And if that database is full of sensitive user info, well, you've just created a massive security risk for yourself.
So, how do we keep our users safe? Well, rule number 1, the big one. Avoid caching any personally identifiable information. Period. If you absolutely have no other choice, you need to put some serious protections in place, like encrypting the entire cache or using keys that are specific to each user so their data can't get mixed up. And finally, always use a TTL. That stands for time to live. It's basically an expiration date that you stamp on your cache data, so you can be sure it doesn't live in your system forever.
All right, we're in the home stretch. Section 6, the ultimate payoff. Let's look at the real-world impact of putting in a smart caching layer.
Look, for any app that gets even a few repeated questions, a good cache hit rate doesn't just lower your costs by a little bit, it can absolutely slash them. We're talking about the difference between a fun side project that's bleeding money and a sustainable production-ready service that can actually scale.
And this table here really brings it all home. You can see each type of cache we talked about, where it lives in your app, and what the #1 benefit is. You've got everything from the massive cost savings you get from an embedding cache all the way to those super fast answers you get with a retrieval cache.
And that really is the bottom line, isn't it? Out of all the complicated, time-consuming optimizations you could possibly do on your AI system, a good caching layer almost always gives you the biggest bang for your buck. It's the perfect trifecta. It makes your app faster for your users, cheaper for you to run, and way more reliable when things get busy.
So I want to leave you with one final question to think about. Now that you've got all these strategies in your back pocket, take a hard look at your own AI projects. What's the one thing, the single highest impact thing you could start caching right now to make your app faster, cheaper, and just plain better?